Hello and welcome to our today's class where we are going to handle our topic 10 under quantitative techniques, which is financial mathematics. Now, financial mathematics is a topic that analyzes the fundamentals of investing, the available finances in a business or in a project for a better return. Normally in a project we are faced with several options, and therefore we have to evaluate these particular options before we arrive at the best possible project to invest in so that we maximize on the returns. Therefore, financial mathematics will help us with the fundamentals of how to determine where should we put our finances for us to maximize on our returns. In financial mathematics, we deal with three concepts. The first one being time value of money concept. Then two, we look at interest, and other interest we have two. We have simple and compound interest. And finally, we'll finish this particular topic by looking at project appraisal. Normally this one is also known as capital budgeting or investment appraisal, and here is where we now make a decision between competing projects so that we decide on one that offers us maximum returns. We'll begin with time value of money concept. And time value of money concept is simply the concept that money received now is worth more than money received later, and later means another time from today. And if I have to pose a question to you, I may ask if you prefer to get some amount of money now or in the future. And most of us will choose now because of the following reasons, and these are the reasons why we study this time value of money concept. People prefer money at the present moment than in future because of several reasons, which include the following. One is that if you receive your money now, then you have a chance to invest that particular money so that it multiplies. And therefore, the first reason is for investment opportunities. Secondly, money that is at hand as a particular now has more purchasing power than money that is received later. And therefore, because of inflation, prices keep rising, and therefore what you can afford now with a specific amount of money cannot be what you afford in future because of rising prices, and therefore people will prefer money now because of changes in purchasing power of that money. Three is the risk and uncertainty, in that if you are to receive money now, it's better than when you receive in future, because in future there are more risks as time goes by, and at the end you may end up not receiving that particular money, and therefore someone will prefer money now because of the risks that accompany it. And therefore, number four, again, the other reason why we prefer money now than in the future is at the present we may have special prices, for example cash discounts and offers that may not arise in future, and therefore one would prefer to have money now to grab that particular opportunity than later, whereby these opportunities may have gone with time. So basically this is the time value of money concept, and therefore people would prefer to receive money at the present than in the future. We'll move to interest, and other interest, as I mentioned, there are two. We'll start with simple interest. And basically, before we go to simple interest, we say interest is the money paid for using someone else's money. Normally, this one usually happens when you borrow, for example, a bank loan, when you have an overdraft, and therefore when you repay, you have to compensate that particular person for using their money, for lending you the money. And in the terms we have here, under interest, we have principal, we have interest rate, time, and amount. Principal is the amount that is lent to someone. For example, if I borrow 50,000, then that 50,000 becomes the principal amount. Interest rate is the discounting rate. This is the charge, the cost of borrowing this money, and therefore it is given as a rate, that is a percentage. Time is the duration taken for you to use that particular amount and repay back that particular principal that you borrowed. Then the amount is the total sum that you have to pay back, which is usually interest plus principal. So the amount consists of usually consists of principal plus interest. This is the amount you borrowed plus the sum you are paying as a charge for borrowing that particular amount. I had already indicated here. Now, when you calculate simple interest, this is usually interest that is charged at the end of that particular period. Once there's a difference with compound interest, as we look at it after this particular subtopic. And how then do we calculate our simple interest? The formula is here. Simple interest is calculated as principal times rate times time over 100. We are dividing by percent because the rate, as I had mentioned, is in percentage. And therefore, to get our simple interest, we'll have to divide by 100%. We have an example here that we use to demonstrate how to get simple interest. And the question says, calculate the simple interest for 50,000 shillings deposited in a bank for 5 years with 9% per annum. And therefore, we are looking at what you will pay back to this bank after 5 years, and the rate is 9%. This is the interest rate. 5%, 5 years is the duration, which is the time, and 50 is the principal. So we are interested in the interest that we pay back. That is the amount we pay back on top of that particular principal. As we had mentioned, the formula is principal times rate times time over 100, and therefore the principal is 50,000. We are multiplying by 9, which is the rate, times 5, which is the duration in terms of years. Then we divide by 100, and our interest is 22,500. An important point to note is that the interest has to be per annum. And therefore, when this interest is maybe quarterly or semi-annual, then we have to convert it to an annual interest rate. Therefore, how do we convert? If we are given this and then the period, for example, here is semi-annually, then the time here has to be more. We multiply by 2. Because this rate now is for, it means in that particular we have two periods in a year. And therefore, the rate, the period has to change. So if we are asked to calculate the amount is simply, as I had shown here, principal plus interest. And this is the amount you are paying on top of the 50,000 that you borrowed. And therefore, the amount is the 50,000 you borrowed plus the interest that you are supposed to pay with it. And therefore, the total gives us 72,500. And using this formula, you can find anything, starting from if we are given the interest and maybe one of these are missing. For example, you are given interest, principal, and rate, and you don't have time, we can manipulate this formula. We simply have to substitute and find the unknown. We'll move to compound interest, and the difference between compound interest and simple interest is that for compound interest, the interest is paid annually. And instead of paying you the interest annually and you withdrawing, you add that particular interest to the principal amount so that the principal continues increasing. For example, if you invest an amount of money and at the end of a year you earn 5,000 on top of it as the interest, then you don't withdraw that 5,000, but instead you will add that 5,000 to the principal so that your principal continues increasing. And therefore, when we are supposed to calculate the amount we are getting, then the formula changes as opposed to the simple interest. In that here, we have P as the principal into 1 plus R over 100 raised to N. And where P is the principal amount, then the A is the total amount that you're supposed to get at the end of that particular period, R is the rate, and N, which is the power, represents the number of years. So for example, calculate the compound interest for 20,000 shillings for 3 years at the rate of 10% per annum. The principal is 20,000, the period is 3 years, which is the N, and the rate is 10%. We say the formula is P into 1 plus R over 100 raised to power N. N here is 3, R is 10, and P is 20. And when we substitute, we get our amount as 26. So remember, this formula gives us the total amount. And therefore, if we are asked to calculate the interest, then we'll apply the formula we had already shown where we say interest is equals to amount minus principal. The same way we are talking about amount is equals to principal plus interest. If we want interest, which we are asked to in part 2, this one was part 1, and what we asked to in part 2, we take the amount minus what we had borrowed, and therefore the interest becomes 6,620. We'll look at example 2 first. To our example 2, Peter has a plan to buy a motor van that is expected to cost 220,000 shillings. He has deposited 80,000 at the beginning and 40,000 at the beginning of the second year. That means 80,000 at the beginning of the first year. Calculate the amount he should deposit at the beginning of the third year if the amount is compounded at an interest rate of 10%. Remember, we said the formula for compound interest is amount. If you want to get the amount, is principal into 1 plus rate over 100 raised to n, where p is the principal, r is the discount rate and the interest rate, and n is the number of years. So here we have been told Peter deposited this particular amount in 3 bits. The first year he deposited 80,000, and therefore the total amount that will accumulate for those 3 years, because we are told it means he wants to raise this 220 in 3 years. So we are being asked for the third year. So the amount at the end of the 3 years on that particular 80,000 is 106,000. If we compound it for 3 years, then it is 106. The second type of deposit that he made, it was a year later, and therefore the period for the first one was 3, but now it is 2, because this 40,000 was deposited at the beginning of the second year. Therefore, it is compounded only for 2 years, and therefore the total amount will be 48. 106 for the first and 48. Since Peter wants to raise a total of 220,000 shillings, then we look at the balance now. Because the total cost of the van is 220, but the first deposit has raised 106, 480. The second deposit, which is 40,000, will raise 48,400. So the remaining amount is the cost minus what he has raised for the 2 separate deposits, which is 65,120. So this 65,120 is what he aims to raise by the third deposit, which he's doing it in the third year, which is only when it is remaining 1 year. And therefore, we are looking for we have the amount, we are interested in the principal, that is the amount they have asked that we should deposit, and therefore P will not have a value, but we have 1 plus R, which is 10. We are told the rate is 10. Then we are raising to 1 because this deposit is to be made at the beginning of the third year. And therefore, when we substitute, we have 65,120 for the amount we are looking for P. This is 1.1, and we are raising it to 1 because the period is 1. Then we get our principal for the third year as 59,200. Now, at the beginning, we mentioned that we are going to deal with 1, time value of money, 2, simple and compound interest, then 3 was project appraisal. Now we'll move to project appraisal. And project appraisal simply refers to techniques that are used by businesses or by projects to determine the best alternative among several projects. When you want to invest, you are always interested in knowing if that particular investment will pay back. That is, you'll get something beneficial, and therefore the techniques we use in determining which particular project is beneficial, that whole process is known as project appraisal. Sometimes we call it project budgeting, sometimes we also call it capital budgeting. The most common types of techniques that we have here are the net present value. Normally we abbreviate it as NPV. We have the payback period, and also we have profitability index, commonly known as PI. We'll start with our net present value as our first technique. And net present value simply refers to present value of cash inflows less the initial investment. and this one is done by use of a discounting table. We'll have an example on how to calculate the net present value so that we are able to calculate at the end. And the example here says XYZ Limited has identified a project which requires initial capital of 150. This is the initial investment in that particular project, and the project will generate cash inflows. An important point to note is that during capital budgeting or project appraisal, there is estimation of future cash inflows, and therefore these are just estimates of what we expect to gain in this particular project. We are supposed to compare them with the initial investment in order to know if the project is beneficial or not. The estimated inflows are given here for the first 3 years. We have 80,000 for the first year, 70,000 and 60,000, and therefore we are being asked to find the NPV for the project. Now, as I mentioned, we usually use a discounting table, and we present the table in this particular format. We have columns for year, for cash flow, for present value, or from that discounting factor, and therefore the total present value. How do we get this discounting factor? Normally, it is 1 plus R. So it is the whole formula for calculating NPV. NPV is usually the sum of the cash inflow over 1 plus R raised to N, where this is the inflow for a particular period, and this is the number of periods, this is the discounting rate. This simply means we are going to discount each particular cash flow. For example, the cash flow for period 1, which is 80, we'll go and discount it. What is to discount? To discount is to convert future cash flow or future value into present value. Is the process of determining the amount in future. What is the correct amount? So the present values, the formula for getting the net present value is summation of the cash flow, C over 1 plus R raised to N. But if we have the discount tables, as I had mentioned, then we don't even need to apply this formula, because you only need to go to the discounting table and read these values. The cost of capital here, capital for the project was 15%, and therefore when you go to your discounting table, then you only need to look at the cash flow and the discounting factor on the column. Then you get all these discounting factors. These two will give us the present values. For example, in year 1, the cash flow is expected to be 80,000. When we discount, which I had mentioned here, and as I said, to discount is to convert. We are converting this future value, which is 80,000, into the present value. The discounting factor will be 0.8696, and therefore the present value is 69,569. For the second one, 70,000, when we discount, we get 52,927, and the third one is 60,000. When we discount using the discounting factor, we get 39,450. Therefore, at the end, we'll find the sum of the present values. And the sum of the present values will be 161,945, as I've demonstrated. Now, NPV is the net present value. Therefore, it's the difference, as we had indicated in our explanation, between the sum of the present values and the initial investment. Our initial investment in this project was 150,000, and the present values, as we have found out here, the total is 161,945, and therefore the NPV for this project will be 11,945. And therefore, if we are asked to calculate the NPV of a particular project, as I said, first of all we discount, then we multiply with the cash flows so that we are able to get the NPV as I've demonstrated here. So NPV is the first technique that we use for project appraisal. The second technique that we use for project appraisal is the payback period. And from the title, it seems here we are looking at the period, that is the time that will be taken to recover the initial investment in the project. And therefore, when we make a decision based on payback period, we will choose the project that is supposed to take the shortest time for us to recover our initial investment. I'll take you back just a bit on NPV. And on NPV, the decision rule on NPV is that if the net present value is positive, for example, here we have positive 11,940, it means when we invest in this particular project, at the end we are going to get a net of 11,945, then we invest in this particular project. That means when we calculate the NPV and we get it as a negative, then we should not invest in that particular project. So NPV is used to evaluate between, it can be one project like this one, or two, you can have several projects and you want to determine which project will give us more returns, and therefore when you calculate you can compare. If you get all of them giving us positive NPVs, then we'll choose one that gives us the highest NPV. Now back to payback period. We said the decision rule here involves choosing a project that gives us the least period as the payback period, because you want to recover the initial investment very fast before you start earning now your money. And therefore, payback period is done in two ways. It has two ways. We have projects that will give you regular cash inflows. I had mentioned earlier and said, in project appraisal, we have estimation of future cash flow. This is money we expect to get, and therefore, if the inflows are regular, in that we expect to get a specific amount each and every time. For example, ABC Limited has identified a project that will cost 200,000 and will generate 50,000 each year for the next 7 years. So the returns here are regular in that we are going to get 50 for year 1, 50 for year 2 for the next 7 years. Then how to calculate payback period is simple. We'll take the initial investment, which is 200,000, then we divide by annual cash flow. And annual cash flow is 50,000, which is a constant. And therefore, when we divide, we get our payback period at 4 years. This simply means when you invest in this project, it will take us 4 years before we recover our initial investment. Now, it can come in another scenario where we have irregular cash inflows. Irregular simply means the amount is not constant. In the earlier example, we have said the amount here is 50 per year, but here the amount is not constant as it is shown here. We are told ABC Limited has identified a project that requires initial investment of 200,000 and generates returns. These are the cash flows as follows. So when you look at these cash flows, they are not regular. For year 1, we have 50, we have 60, we have 70, we have 80, and we have 90. We cannot apply this formula here because the inflows are not regular. And therefore, we have a different formula when the inflows are regular, as we are going to show here. How then do we calculate the payback period? I've just shortened it. How do we calculate the payback period? We will add these particular inflows cumulatively. And I take you back here. Cumulatively in that, the initial investment here is 200,000. And you see year 1 we are getting 50, year 2 60, year 3 70, year 4 80, and year 5 90. We will add these inflows cumulatively until we reach a point where when we add the next inflow, then the amount is more than the initial investment, which is 200. And therefore when we add cumulatively 50 plus 60 plus 70, we are at 180,000 for the first 3 when we add cumulatively. 50,000 plus 60,000 plus 70,000. We get a total of 180,000. That simply means when we add The fourth inflow, which is in year 4, will be going over the 200,000, and therefore it means we require the first 3 years plus a section of the 4th year. And that is from our formula here, as I've indicated. We'll add cumulatively so that we get the years that give us an amount that is near full recovery. And the full recovery amount here is 200,000. Then how do we get that particular section that is remaining? It will be the balance that is remaining for us to get our full amount divided by the inflow for that particular period. The next period is year 4, and the inflow for year 4 is 80,000, as we have indicated here. So our years to full recovery is 3, because as we have added cumulatively, then what is remaining as the balance is 200,000 minus that cumulative amount, which is 180. Then we are dividing by 80, which is the inflow for year 4. 200,000 minus 180 gives us 20, and therefore this is like 3 plus 20 divided by 80,000, which is 3 plus 0.25, and therefore at the end we get 3.25 years. Alternatively, you can also convert this into months by multiplying by 12 months in a year. So at times you may be asked to calculate the discounted payback. And the discounted payback, we have already learned on how to discount. First of all, when you are given the inflows, you will discount the inflows before you follow this particular procedure. And finally, I've just mentioned and said, this is for inflows that are not regular. And therefore, most projects usually involve this because it is not that possible that the inflows will be just a specific amount for every year. The third method that we use, or technique that we use to do project appraisal, is known as profitability index. This is more or less the same as the NPV, only that at the end, when we are calculating our profitability index, we divide the summation of present values divided by the initial investment. When we come here, under NPV, we said we'll take the summation of the present values, then we subtract. So NPV is a value, but profitability index is a ratio. And we have explained and said is the ratio of present values of cash flows over the initial investment. Now, the ratio here, we are using this example that we had here, where we discounted and got our summation of present values at 161,945, and our initial investment was 150,000. And therefore, when we are asked to calculate the profitability index, it will be 161,945, which is the summation of the present values divided by the initial investment, and we get our profitability index as 1.0796. The decision rule here is that if the profitability index, PI, is greater than 1, and greater than 1 simply means it is more, and therefore we are getting something on top of our investment, then we should invest in that project. If we get something that is less than 1, for example 0.9, 0.8, then we should not accept that particular project. Thank you, and see you in our next lesson.